Welcome everybody to lesson number 4, rotational solids. This is also the last lesson for this geometry course. And what a better way to end this than a really super duper easy lesson. Okay, we've gone through a lot of really difficult stuff and I'm very proud of all of you for making it through. I'm going to dedicate this particular lesson to the graduating class of 2019 because I worked with those a lot of those kids, and I had them for geometry and pre-calculus, and I think that they earned this one. So here's to you, class of 2019. Uh, Lesson number 4: rotational solids. So a rotational solid, it's exactly what it sounds like. You take a something, you rotate it, and you make it solid. Now, there's lots of applications why you'd want to use these in real life. If you're designing any kind of thing in space, you want to see where it might take up space, especially if it moves. And things that move often rotate. If you think about, for example, turbines spinning around, right? Those things move with the wind a lot of times. So you don't want those turbines to spin and hit something else. So you got to think about the solid space around it that it could potentially run into. And that's just one thing that you can do with rotational solids is figure out what it looks, what something might look like. Another thing is you can use it for design. People use them to design chair legs and such with carpentry and woodworking. Other designs can be used. And then just in general mathematics, we can use them to figure out gas tank sizes, all sorts of things. So rotational solids, pretty useful. And again, super easy to do. So let's get right into it. You have an axis, and then you have a figure that we're going to turn from a two-dimensional drawing into what will be a rotational solid. Quick just caveat on this. Some people can see this way clearer than others, so I can't promise you that you'll definitely see what's going on. Some people will be like, oh, that's 3D right away, and others, you might not see it. It's kind of like an optical illusion to them. Okay. Here's the steps. If you want to write these down, I have it memorized. It's pretty easy. The best way to draw the rotational solids. We're going to draw the reflection across the axis. So this original shape, we're going to end up drawing the reflection of it on the other side. We're going to make ovals at critical points. If I were to quickly sketch the reflection, this is just a quick sketch, but we have some critical points, right? This very corner here and here, this point here, this one here. These are pretty stand out points. I call those critical points. Okay, and then mention something about ovals. We'll go over that in a minute. We're going to make more ovals in between. So even though we've picked out these 4 points, we're going to want some more in between. And then it says the more you draw, the clearer it will look, and it's good for overlaps. So how do these ovals work? Well, if we're rotating this object around and around and around, we've got to imagine that this corner is going to be traveling through space. Right? It's going to go up till it hits the axis, and then it's going to start coming back down to this side, which we already reflected, because we knew it should look the same on both sides, basically. So what we're going to do when we're drawing all of these, how I'm going to do it, is I'm going to draw just one side of the ovals at the same time. Then we have to imagine now that this thing comes back up. So it's going to continue out like an oval and then start coming back in. It's okay for them to be pointy. It actually kind of adds to the 3D look. Okay, so that's how those things will be drawn. As it mentioned, we need to have a lot of overlap. So I'm not going to continue with this particular example. I want to draw one right from scratch. Okay, so here's what you're going to do. Pause the video and copy this image and resume when you're ready to do this with me. Alright, so step by step, first of all, we want to reflect. Do the best you can, making it look the exact same. Okay, is mine perfect? No. It's as close as I could get. Okay, it actually looks a little shallow on this side. It should probably be a little bit wider, but that's okay. We're going to start off by drawing some critical points. Here and here match. Here, here, at the bottom of these kind of slanted spots. Okay, so quite a few points. I'm also going to consider a few in between. I can probably fit 2 in between here, maybe 3 in between here, another 2. And I can even do some on the diagonals if I wanted to. Okay, I'm not going to force anybody to do this many. You do, however, have to have at least 8 or 10, depending on the shape. Okay, but here's what we're going to do. I'm going to go and I'm going to connect all one direction first. And by drawing them out first, it's a lot easier to remember where to go. Okay, so I've done one side. I already can see it kind of looking 3D-ish to me. But once I start drawing in the other sides, including the overlap on the ovals, it's going to look a lot more three-dimensional. So now I'm going to go back, and it's just a little bit trickier, but I got to keep track where I start and where I end. I'm ending here. There you go. To me, what I can see, kind of looks like a 3-tiered wedding cake, right? You got the bottom layer, middle layer, and the top. Okay, but that's a rotational solid. We went from a two-dimensional flat figure here, and we managed to turn it into this 3-dimensional shape. And you can actually see a little bit more to it. It's not; these are not flat here, right? These are kind of like angled. So if you want to pause the video and do all 3 of these, or if you want to pause the video and then watch this one and then try these 2 afterwards, however you want to do it. What I'm going to do is all 3 of these all at the same time. So however you want to do this, pausing and watching and pausing, that's up to you. But I would copy them all down, and I'm going to go right through them all together. So do it however you feel, pausing the video. This is the last one, guys. This is it. Last 3 problems, and you're done with geometry. Alright, let's see. This one's a little curvy. It goes about to here, before it comes back up to midway. Again, not perfect, but pretty close. Okay, I have some critical points. I can see those lining up. Maybe one here, a couple here, the very tippity top. And again, the more that you put, the more accurate this will look. We do one side first, so we'll do the inside this time. Okay, so those are all one side. Already I can see it kind of jumping off the paper. Kind of looks 3D to me. If you were to add some shading in there, I bet you anything you could see it. But we want to do the other side, give it the full three-dimensional shape. By the way, this technique can be used for all sorts of things. Designing three-dimensional objects before you print them out in a printer. We have 3D printers now, so that's something that you can do. Right? That kind of looks like a basket of sorts to me. Maybe you would keep a king cobra in there or something, right? But all sorts of applications for this that you can use. We can also use them in art class. I mean, just making some cool looking structures in art class is enough. So these were the other two that you could have paused the video and tried on your own. If you haven't done those yet, then pause and try them. I'm going to go over them right now. Alright, for this one, we've got to go out, over, out a little bit more. Sharp drop. Oops, too much of a drop. And then over. A little bit's not a big deal. Alright, here's some major points. By the way, I turned the paper because it's way easier to work with. So don't be afraid to do the same thing. Now, I have some points that are lined up. I can do those as well. That's not a problem. I need some more points. So I'm going to do like maybe 2 in here. Maybe 1 in between. Maybe 2 in between here. And maybe 2 more here. Okay. Either direction doesn't matter first. Looking at this, I probably want another one here. I'm probably going to want one here. And that's okay. You can go back and add some if you want. It's not going to hurt it. In my opinion, it only makes it look cooler. I will say this, this is probably not the most exciting video to tune into if this is your first Marchetti Math video, but as far as how to make these, this is probably the best video out there, my opinion. Okay, again, I see a really cool three-dimensional figure. I see this thing that looks like a top that you would spin around. Right, this is the bottom. That's what I see. We got one more for you to sit through and watch. If you haven't done this one already, you don't even have to sit through. You could have probably fast forwarded to see what the final product looked like by now, for all I care. Anyways, we got one more to do. It looks like it's going to go to about here, over, and then it dips down a little bit, and then it comes way up, and then comes back down. Critical points. Alright, I might want to add a few more. Right? Maybe add 2 in here. 1 in between. Then we'll go the other side. That one looks ugly, but that's okay, because that's the last problem that you have to sit through. In fact, you didn't have to sit through any of that. You could have fast forwarded. This could have been really quick, but it is definitely an easy one to end geometry with. Again, I'm very proud of everybody who accomplished this course. This is it. That's it for geometry. So, on to pre-calculus. If you haven't taken that course with Mr. Marchetti yet already, I'll see you there. Good luck and goodbye.